As a star exhausts its fuel, it enters the final stages of its life cycle. During this period, the star undergoes significant changes, ultimately leading to a spectacular explosion as a nova. Stage 1. Helium flash. As the star's hydrogen fuel is depleted, the core begins to contract and heat up. This causes the helium at the core center to ignite, triggering a brief helium flash. The helium flash lasts for a few thousand years, during which time the star's surface temperature increases. Stage 2. Helium core. After the helium flash, the star's core becomes increasingly hot and dense. The helium core begins to contract, causing the star's surface to expand and cool. This phase is known as the helium core phase. Stage 3. Carbon burning. As the helium core continues to contract, the star's core temperature rises to the point where carbon fusion becomes possible. The carbon at the core center begins to ignite, triggering a carbon burning phase. During this phase, the star's surface temperature decreases, and the star becomes a red supergiant. Stage 4. Neon burning. As the carbon core continues to contract, the star's core temperature rises to the point where neon fusion becomes possible. The neon at the core center begins to ignite, triggering a neon burning phase. This phase is shorter than the carbon burning phase, and is characterized by a slight increase in the star's surface temperature. Stage 5. Oxygen burning. As the neon core continues to contract, the star's core temperature rises to the point where oxygen fusion becomes possible. The oxygen at the core center begins to ignite, triggering an oxygen burning phase. This phase is shorter than the neon burning phase, and is characterized by a slight increase in the star's surface temperature. Stage 6. Silicon burning. As the oxygen core continues to contract, the star's core temperature rises to the point where silicon fusion becomes possible. The silicon at the core center begins to ignite, triggering a silicon burning phase. This phase is shorter than the oxygen burning phase, and is characterized by a slight increase in the star's surface temperature. Stage 7. Iron core. As the silicon core continues to contract, the star's core temperature reaches the point where iron fusion becomes possible. The iron at the core center begins to ignite, triggering an iron burning phase. However, this phase is extremely short-lived, lasting only a few seconds. The final frenzy, the nova explosion. As the iron core continues to contract, the star's core temperature reaches the point where nuclear reactions become unsustainable. The star's core begins to collapse, causing a massive release of energy in the form of a thermonuclear explosion. This explosion is known as a nova. During the nova explosion, the star expels a significant amount of matter into space, including heavy elements such as iron, nickel, and gold. These elements are forged in the star's core through nuclear reactions, and are then released into the cosmos, enriching the chemical composition of the surrounding space. The aftermath, a white dwarf remnant. After the nova explosion, the star's core is left as a hot, compact remnant known as a white dwarf. The white dwarf is composed primarily of carbon and oxygen, with a small amount of heavier elements forged during the star's life. The white dwarf will slowly cool over time, eventually becoming a black dwarf, a cold, dark, and nearly invisible star. In conclusion, the final stages of a star's life cycle are marked by a series of nuclear reactions, culminating in a spectacular nova explosion. This explosion releases a significant amount of matter into space, enriching the chemical composition of the surrounding space, and forging heavy elements that will eventually be incorporated into the formation of new stars and planets.